Thank you. And it's really an honor and pleasure to be here. And I sincerely thank the organizers of this particular meeting for inviting me here. And I don't think that I need a microphone because this room is reasonably small in size, so I can move around and I can kind of deal without a mic. I don't know whether the mic is necessary, but anyway. So when I was asked to give this talk, I don't know the contacted me. I asked one thing that, I mean, since I work in different disciplines of this high energy physics and gravity, so what kind of talk is expected? Because I know that this is to commemorate this 100 years of gravitation, the general relativity. So I thought that I may be talking on the interface of high energy physics and gravity, and how even in Large Hadron Collider we are thinking about detecting black holes, etc. But there are many other different disciplines in which we are working in our group. So it's a large activity, different kind of activities. But then I came to know that the aspects of the gravitational wave is not going to be discussed in this meeting. And so I was told that maybe some introduction in this area will be useful. So as a result, I will talk about the gravitational wave, its discovery. I won't talk much about our work in our group because very recently we have completed one work with some members of IOCA. But that it's a technical work, but I will mention it at the end. But the purpose of this talk is to explain what is gravitational wave, and it is not, and particularly in the context of the detection, which has created sensation all over the world. So why we consider it one of the major discovery of the century, and the background, everything. The purpose is not to tell you about all the technical details of this gravitational wave, because that is not possible in a single lecture or a couple of lectures. But I will try to tell you the entire background, the scenario, the story behind it, and how it came into existence, and maybe at the end some of the recent works in this context. So, as you can see the title, Voice of the Cosmos, Einstein and the Gravitational Wave. The title will be explained as we proceed. So, this is a magical moment in 14th September 2015, when for the first time we have heard the musical voice of the cosmos. And this contributed again on 26th December 2015, and then again. So what you have read in newspaper that we have detected what is called gravitational waves. So my purpose is to tell you why this discovery is so important. So that is the purpose of the first part of the lecture, and then of course we will go on to the main aspects of gravitational waves. So to understand this, first you need to know about the dimensions of this entire universe about which we are talking, because this is all numbers are always important, and you know that our planet Earth is around 12,000 kilometer diameter, which is quite big in size, you will agree. But then the Sun, which is our closest star, has this size. And then you can imagine that the solar family, which roughly has a size approximately 10 to the power 9 kilometer. And then the galaxy, which the solar family we have our Sun, and the galaxy contains about 10 to the power, our Sun is roughly an average star, about 10 to the power 11 such stars with size 10 to the power 18 kilometer. You can imagine how the things are really becoming bigger and bigger. And then of course, for the last slide, there are 10 to the power 11 such approximately galaxies with average distance 10 to the power 20 kilometers. So if you can now imagine that we are sitting somewhere, not even a point probably, sitting somewhere here and trying to understand about this whole universe. So this will tell you about the dream that we are trying to finally achieve, and this is absolutely enormous. So now we are sitting on this earth somewhere here, and we want to understand everything. And understanding means communication. If you want to receive information, and even any kind of communication, if you want to communicate, suppose if I want to communicate to you, then there has to be some mode of communication among us. So in order to have knowledge, in order to convey knowledge, in order to do anything, you need to communicate. So how to communicate from one point to another, to a distant region, or one point to another, how to send information and receive information from one place to another, because you know that you are receiving information from me, and the entire, even on this earth, we are constantly doing this, sending informations and receiving informations. So the question is, how do we do this? Without this, we don't exist. To understand this, we need to go to something very fundamental, what are called the nature of the forces. Now, we know that force is the cause of all changes or dynamism in nature. This actually Newton taught us many years before, that force is a crucial thing. Without force, a static body will remain static, and uniformly moving body will move uniformly. So if the whole universe will be very uninteresting without the presence of force. The force is actually the cause of all really funny things happening all around, even everything what is happening in the universe. And therefore, the nature of force is an important point to understand. And we find that there are two main forces. One is called electromagnetic forces and other is gravitation. Of course, you will tell me that there are two more forces called nuclear forces, strong and weak nuclear force. But you have to understand that those forces have a very characteristic difference from these two. Those forces are short-range force. Short-range force means they operate only at a very short distance. So unless you can go to a distance level within the nucleus, size of the nucleus, you can never perceive the nuclear force, because it falls very quickly with distance. So the nuclear forces are perceptible at a microscopic level only, unlike these two forces which are extended up to infinity. This statement is true for both the nuclear forces, weak nuclear force and strong nuclear force. Therefore, unless we deal with very high energy with which we can come very close to a point, then the importance of these two forces are not that much. They have their importance at a different level, different reason, different cause, but as long as the usual distance with which we communicate, we talk, these two forces has no role. So we have only two candidates in our hand. One is electromagnetism, other is gravitation. Now, among these two forces, or between these two forces, if we focus into electromagnetism, we know from our school days that if there are two electric charges, then you have learned the lines of forces, electric field between the two charges and their electrostatic force exerted by one charge onto the other, and this is extended for a very long distance, in fact up to infinity. So electromagnetic force is a long range force. So this is electric force or electrostatic force, the force between two static charges. Now if a charge starts moving, and moving charge called current, we have studied, these are very fundamental high school knowledge, this current, and current produces, apart from the electric field that I have shown in the previous slide, an extra additional field called magnetic field. So magnetic field is caused by moving charge or current, and electric field is caused by static charge. But even static charge can have electric field, but only the moving charge can have magnetic field. So at the source of electric and magnetic field, both are charges, electric charges. And since it's the same source, and it's because of the motion the magnetic field is produced, you know that if you move, suppose this charge is static with respect to you and see only electric field, but if you start moving, then with respect to you this charge is also moving, because you are moving, therefore charge is moving in the other direction. As a result, your new frame, in your new moving frame, you will feel that the charge is moving, and therefore you should see a magnetic field. And but I know that we know that from one frame to another moving frame is related by a transformation called Lorentz transformation. And therefore, relativity immediately tells us that electric and magnetic field should be unified, because it's just a perception between two frames. And therefore, what happened, this electric and magnetic field are initially described by Coulomb's law and Faraday's law, which we learned, but then this combination that one leads to other, because of the motion, electric field change of, when the charge moves, the electric field changes with time, because it is moving, the electric field changes, the distance changes of the charge between this point, therefore electric becomes time dependent, and time dependent electric field produces magnetic field. So this electric and magnetic field are related by a set of equations called Maxwell's equations. And therefore the equations are this, so that you can see that the time rate of electric field produces magnetic field and so on. So these are the equations which connect the electric and magnetic field in free space. That is not in any medium. In medium the things becomes a little more complicated, but this is in free space. Now with this knowledge, what people did, people developed the idea of electromagnetic wave. These equations also show, these four equations that I wrote, Maxwell's equation, that when the electric charges accelerate, now suppose instead of uniform motion, the charge starts accelerating, then the electric and magnetic field which was created, they start moving. So it's a very simple mathematics from previous four equations. They start moving and they start traveling in space. And this moving electric and magnetic field is called electromagnetic wave. Now this is the picture of electromagnetic wave. You can see that the wave is an oscillatory wave, you know the usual concept of oscillation. And it turns out that if the electric field is in this direction and magnetic field in the perpendicular direction, the motion of the electric and magnetic field is in the another perpendicular direction. So there is called transverse wave, because the direction of the propagation of wave is perpendicular to the electric and magnetic field directions. So this can be derived mathematically from these four equations, and in fact if I try to write the equation of a wave, it is the standard equation of a wave which tells you that the second derivative of if the wave is a kind of disturbance at a point, which for electric and magnetic field you can imagine the amplitude of the electric and magnetic field, and that satisfies this equation, that it propagates in space and time following this equation, where v is the velocity of the moving wave, and this is the amplitude of the electric or magnetic field, whatever you can take here, and this is this equation they satisfy. So what is the advantage of this? Advantage is, moment we discovered this, then we found from Maxwell's equation that electric and magnetic field satisfy this equation, which tells us that they propagate with speed which is speed of light. So we learned from this, because I told you that the standard wave equation is v is the velocity, this is the velocity of the wave. So if you now compare, we find that this c is the velocity of the electric and magnetic field propagation. So electric and magnetic field starts moving towards a direction which is perpendicular to electric and magnetic field themselves with a speed c, and they are called transverse wave, and this is what is known as electromagnetic wave. And then once we come to know, and this happens when the everything has an origin electric charge, when that accelerates. When that accelerates, this will happen. So suppose you take electric charge, you oscillate it. Oscillation is an acceleration, it emits electromagnetic waves. Now what happened, this we learned that this was a thing we are looking forward to. So for example, light ray, X-ray, etc. are electromagnetic wave. They travel in space with speed of light, all are electromagnetic wave, but only they have different frequencies. The frequency of wave is different, how quickly they are changing the amplitudes. And remember, this is our only mode of communication in modern civilization, because exactly this way we communicate, whether you are talking over a mobile phone, or you are seeing television, what happens, we capture the information at one point and we convert it into electromagnetic wave. We propagate, it travels with huge speed of light, and it comes on your television screen, and you can see the cricket match going on in England, sitting in India instantly. And you talk to your friend over mobile. This is exactly the way what you do. Your mobile set converts it into electromagnetic wave, it communicates. And even so, everything has its understanding of communication through electric and magnetic wave. So this is a very, very important property, the property of communicating signal through the form of electricity and magnetism. The two important force of nature. So this is the wireless communication. We create one point, it goes and it receives at another point. And we all know, but I don't know how many times we remember that this such a big discovery. I mean, on which the entire civilization stands was done by Sir J.C. Bose in our state, in our city, Kolkata. But now world has recognized it, acknowledged it, but somehow we tend to forget it so easily. So this is probably one of the most incredible discovery of the human civilization, and done by our own somebody who is an Indian. Now, of course, the vital question comes: what happens from gravitational force? Does gravitational field also travel like a wave with a finite speed? This is important because, see, the other two forces cannot do this because they are short range. So the only option, other mode of communication you have, is whether the gravitational force, which is also extended up to infinity, like Coulomb's law 1 by r square, gravitational force is 1 by r square. Can gravitational field also travel like a wave as electromagnetic field does and become a mode of communication? And in that case, if it can, then we do not need electric charges. But since gravitational force, according to our old idea, is generated by mass, therefore even from a mass you can generate waves and communicate. So you can have maybe a mobile set without any need of a battery. So the question is that first question, forget about creating a mobile. First question, does gravitational field travel like a wave with a finite speed? This issue has to be settled. To settle the issue, you go back to your own knowledge of Newton and force of gravitation. What happened? Newton taught us a remarkable theory. The theory is the following: that the force for which the apple falls on the earth because of the gravitational attraction is the same force which keeps the planets moving around the earth, around the sun. So this is certainly a remarkable discovery because it tells us that gravitational force has universal character. It depends only on the two masses which are attracting each other. This has a mass m, this has another mass m. They are attracting each other, where this r is the distance, and this is the magnitude of the force. Now you can see one interesting thing, that this value of this constant, which is called Newton's constant, which is proportionality constant, the force is proportional to the product of the two masses and inversely proportional to the square. This proportionality constant, Newton's constant, has a very, very small value. And the value is so small that unless the masses are very, very large, this force is not perceptible. You cannot see this force easily, because otherwise see, I am standing here, that chair, and we should come and collide with each other because we are attracting. But we are not doing it. Why? Because the force is there, but force is so small because of the smallness of Newton's constant, therefore it cannot overcome the frictional force. So this force, as Newton pointed out, will be visible, will be observable unless at least one of the masses is very, very large, so that this quantity can be large. And for this reason, when you are talking about the motion of this going down, at least mass of the earth is very large, and therefore it is attractive. and if both the masses are large, which is fine. There is another situation where this force can become very large, when the distance between the two particles becomes very small, because then this R will be very, very small. Now, when the distance between two particles can be very small, because if you can pull them very, very close, and in order to do that, you can have huge energy to bring them very close. So, we believe that at a high energy domain, the gravity can become an important force, even for small particles. So, for this reason, the gravitational theory is now closely integrated to particle physics, because now we have attained very, very high energy. You know, the large hadron collider we are coming very, very close, and therefore whether the gravity becomes a strong force because of the smallness of particle. But for the moment, let us assume that we are dealing with reasonable quantity objects, and these are the reasonable sized object, and this force is has this large value only for large masses, and otherwise this force is negligible. And Newton explained the planetary motion very, very successfully. You know, that is the Kepler's law. Planetary motion can be explained by this. So Newton's law met with tremendous success, and according to Newton, gravitational field acts instantaneously and does not travel like a wave with a finite speed. Okay, how does he know this? He knows this in the following way. He showed that the gravitational field that I have written here, F, this field, this is the force on small m by capital M. So if you divide by small m, this is called gravitational field. Gm by r squared is the field of m at this point r. This field can be written through a potential phi, which is Gm by r, and the gradient of the potential is nothing but gradient of the potential in the field. And if you calculate the square of this from that equation, you will find that this is 0. It's very simple mathematics. Very, very simple mathematics to show that del square phi is 0. And once you show that del square phi is 0, then remember